Very good morning, dear students. Today we start with chapter number 25, probability. Probability means the chance of occurrence of anything. किसी चीज दे होने दे chances. In our daily life, we generally use the word like most likely, almost uncertain, most probably, no chance at all. Like in these days, the IPL is going on. ਐਂਡ ਆਪਾਂ ਕਦੇ ਕਦੇ ਪ੍ਰੈਡਿਕਟ ਕਰਦੇ ਹਾਂ ਕਿ ਕਿਹੜੀ ਟੀਮ ਜਿੱਤੇਗੀ ਕਿਹੜੀ ਟੀਮ ਹਾਰੇਗੀ ਇਸ ਪਾਰਟਿਕੂਲਰ ਬੈਟਸਮੈਨ ਦੇ ਕਿੰਨੇ ਸਕੋਰ ਹੋਣਗੇ ਜਾਂ ਕੋਈ ਕ੍ਰਿਕਟਰ ਜਿਹੜਾ ਬੋਲਰ ਹੈ ਉਹ ਕਿੰਨੀਆਂ ਵਿਕਟਸ ਲਏਗਾ ਮਤਲਬ ਇਸ ਤਰ੍ਹਾਂ ਦੀਆਂ ਗੱਲਾਂ ਥੀਸ ਕਾਈਂਡ ਆਫ ਥਿੰਗਸ ਆਰ ਕਾਲਡ ਟੂ ਡਿਸਕਸ ਵਿਦ ਦ ਪ੍ਰੋਬੇਬਿਲਿਟੀ ਸੋ ਜਿਵੇਂ ਕਿ ਇਟ ਮੇ ਰੇਨ ਟੂਡੇ ਔਰ probably he will go out of station today. These kind of things are all comes under the probability. And probability is very important as well as an easy chapter also. So before we start with the probability, let us have a look on some basic terms and concepts. Now first is experiment. Experiment ਦਾ ਮਤਲਬ ਹੁੰਦਾ ਹੈ ਕਿ ਕੋਈ ਵੀ ਚੀਜ਼ ਜਿਹਦੀਆਂ well defined outcomes ਹੋਣ. A process which result in some well defined outcomes is known as experiment. And the very simple example is tossing a coin. When we toss a coin, the outcomes head or tail, and it is the fair mean to decide which teams bat first or bowl first. ਦੇਖਿਆ ਨਾ ਕਿ ਜਦੋਂ ਕ੍ਰਿਕਟ ਮੈਚ ਦੇ ਵਿੱਚ ਸਟਾਰਟ ਹੁੰਦਾ ਮੈਚ ਤਾਂ the umpire will toss a coin to decide which team will bat first. And similarly, when a die is thrown, the possible outcomes are 1, 2, 3, 4, 5 and 6. And random experiment, ਜਿਵੇਂ ਆਪਾਂ ਹੁਣ experiment डिस्कस किया रैंडम एक्सपेरिमेंट जिदियां आउटकम्स अपन पता जिवें ऊपर दो एग्जांपल अपन ने कंसीडर किए ऑल दीज थिंग्स द आउटकम्स आर ऑलरेडी known. So random experiment means all the outcomes of the experiment are known in advance, but any specific outcome of the experiment is not known in advance. देखो all things are experiment, but in random experiment we know the outcomes but we cannot predict which outcome will come. Like in tossing a coin, we know the outcome is head or tail, but we cannot predict which comes actually. So the random experiment and experiment, basically they are the same thing, but in random experiment we cannot predict the outcome in advance. So there are various examples. Then the third term is sample space. Sample space means the collection of all possible outcomes of an experiment. So what is sample space? Sample space means the collection. Collection is also known as set. So the set of all possible outcomes of an experiment is called sample space. And generally it is denoted by the capital letter S. S ਦੇ ਨਾਲ ਆਪਾਂ ਇਹਨੂੰ denote ਕਰ ਸਕਦੇ ਹਾਂ. Like here are some example. So when we toss a coin, the outcomes are head or tail. So sample space. Generally sample space is written like this. Here you can see S. S is the symbol and H and T are the possible outcomes. So these things are enclosed within the brackets. So the sample space is H, T. Similarly, when we throw a die, then outcomes are 1, 2, 3, 4, 5. So S, sample space, is the collection of all these numbers. Similarly, if you throw two dice together, then there will be a pair you obtain. On first die you will get some number, on second die you will get another number. So these numbers are denoted like pairs. So sample space has 36 outcomes when you roll two dice together, and the combination like 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, etc. up to 6, 6. And similarly, there are another combinations also. When a coin and a dice are tossed together, different outcomes you can see in this sample space. Then comes equally likely outcomes. Equally likely outcomes. Equal means same. Likely means barabar barabar, equally likely. So equally likely outcomes are those outcomes, the probability of occurrence of those are equal. So generally in a sample space, all outcomes are equally likely. Then an event. Event is basically outcome of a random experiment. And in other words, we can say event is something which happen is called event. And the formula for the probability, so the probability of an event denotes the likelihood of its happening. That means how much are the chances of occurring of an event. And probability of happening of an event E is given by number of favorable cases to event E and total number of all possible outcomes, means in how many ways the outcomes favor out of the sample space to that particular event, and what are the total number of outcomes. For example, if we consider the case of tossing a coin, we know there are two outcomes, one is head and another is tail. So if we want to calculate the probability of happening of head, so to head there is only one favorable case and total outcomes are 2. So it is 1 over 2. Similarly, we can calculate the probability of another things also. Then there is another thing that is related with probability of happening, that is probability of happening and probability of not happening of an event. Now here you can see if E is an event, then its probability is called probability of happening of that event E. And there is another event that you can see over here, E bar. E bar is called complement of event E or not happening of E. So probability of E and probability of not E, they are related. Every time when you add the probability of E and probability not E, then answer is always 1. So this is the result, probability of not E is equal to 1 minus probability of E. There are some other results that you have to remember. These are, one is impossible event. If the probability of occurrence of an event is 0, it is called impossible event, that you can see over here, the definition is written over here. And if the probability of happening of an event is 1, then it is called sure event. So sure event is that event in which probability of happening is 1. Sure event is also called certain event. And always the probability of occurrence of any event lies between 0 and 1. It could be 0, it could be 1. And its value maybe lies between 0 and 1, but the probability of an event can never be negative and probability of an event can never be greater than 1. There is one more thing, all of you have the knowledge about the playing cards. So because in probability we need the description of the playing cards. So in some questions we have to deal with the cases of playing cards. So here is the look. A deck of playing card consists of 52 cards. And these 52 cards are further divided into 4 suits. These 4 suits are, first is spade, second is hearts, third is diamond, and the fourth is club. Out of these 4 suits, spade and clubs, these are black in color, hearts and diamond, these are red in color. In every suit there are 13 cards. So it means every suit has 13 cards, so total 52 cards. And as we already discussed that spades and clubs, they are of black in color and hearts and diamond are red in color. So it means 50% card, that is 26, are black and 26 are red. Then in every suit out of the 13 cards, 4 cards bear alphabets like A, K, Q and J. A means ace, K means king, Q means queen and J means jack. And numerals 10, 9, 8, 7, 6, 5, 4, 3 and 2. So in every suits we will find the cards bearing number 2 to 10 and alphabets A, K, Q and J. King, queen and jack are also called face cards because a face is printed on these cards. So a deck of 52 cards contain 4 kings, 4 queens and 4 jack. It means total number of face cards are 12. So further we can classify these as red and black. So red face card 6 and black face cards also 6. So total face cards 12. Students, now we start with exercise 25E. First we start with question number first. Now see the statement of question number 1. It is, a coin is tossed once, find the probability of getting a tail, and second part is not getting a tail. So here is the solution. So total outcomes when we toss a coin are 2, head and tail, and we name the event in first part as E. So E is the event of getting a tail, and we know that favorable outcomes to E is 1, only one tail is in the sample space. So probability of E, as we know the formula, it is favorable outcomes over total outcomes. So probability of E will be 1 by 2. Then in second part, we have to find the probability of E bar. The second part is the probability of not getting a tail. So not getting a tail means complement of E or not E. So probability of not E, as we know, is equal to 1 minus probability of E. So probability of E complement is 1 minus 1 by 2. That is 2 minus 1 over 2. So probability of E complement is also 1 by 2. Now we shift to question number 2. First we read the statement. So it is, a bag contains 3 white, 5 black and 2 red balls, all of the same shape and size. Means we cannot check without seeing it which color it is. So a ball is drawn from the bag without looking into it, and we have to find the probability that the ball drawn is black ball, red ball, white ball, not a red ball, not a black ball. So let us see the solution of this one by one. In first part, first of all, we will write total balls. 3 white, 5 black, 2 red. So total balls are 10 and ball drawns 1. So it means total outcomes will be 10. In first part, we assume E1 as the event of getting a black ball. So favorable cases, how many balls are black in color? 5. So favorable cases or favorable outcomes will be 5. And again, we know the probability formula, favorable outcome over total outcome. So probability of E1 will be 5 over 10, that is 1 by 2. Now the second part. In second part, we have to find the probability of getting a red ball. So total number of red balls 2. So it means favorable outcomes will be 2. So probability of E2 is 2 by 10, that is 1 by 5. In third part, we have to calculate the probability of getting a white ball. And how many balls are white in color? 3. So it means probability of E3 is 3 by 10. Now, fourth part is event of not getting a red. So there are 2 methods to solve this. First, E4 is complement of E2 because E2 is getting a red ball and E4 is not getting a red ball. So it means these 2 are complementary events. So it means probability of E4 is equal to probability of E2 bar, that is 1 minus probability of E2, 1 minus 1 by 5. Take LCM. So when you take LCM, it is 5 into 5 minus 1 by 5. So probability of E4 is equal to 4 by 5. And the alternate method is direct method. E4, event of not getting a red ball. So if you will not get a red ball, then the color of the ball will be white or black. So favorable outcome are 3 plus 5, 8. So probability of E4 is equal to 8 by 10, that is 4 by 5. So now you can solve the fifth part similarly, not a black ball, either directly or by using the formula for complementary events. Now, question number 3. In a single throw of a dice, find the probability of getting a number which is greater than 4, less than or equal to 4, or not greater than 4. So here is the solution. Now, when we throw a die one time or single time, then total outcomes will be 6. These are 1, 2, 3, 4, 5 and 6. In first part, we assume even as event of getting a number which is greater than 4. So greater than 4, there are 2 numbers, 5 and 6. So it means favorable outcomes to E1 are 2. So therefore, using the formula favorable outcome over total outcome, the probability is 2 by 6. That means 1 by 3. In second part, we name the event as E2, and the event is to getting a number which is less than or equal to 4. Now, the number which are less than or equal to 4 are 1, 2, 3, 4. So favorable outcomes to E2 are 4. So probability is 4 by 6, that is 2 by 3. In third part, E3, we have to find the probability of event of getting a number greater than 4. Again, this can be done by two methods. First is method of complementary events. We can see that E3 is complement of E1 because in E1, the event is number greater than 4 and in E3 number not greater than 4. So these two are complementary. So by using complementary formula, so probability of E3 is equal to probability of E1 complement, that is 1 minus probability of E. Probability of E1. E1 is 1 by 3. So 1 minus 1 by 3, it will give probability of E3 equal to 2 by 3. In alternate method, we can directly assume if we choose alternate method, E3, event of getting a number not greater than 4. So not greater than 4 matlab the number will be less than or equal to 4. Now it become equal to E2. Same, E3 and E2 are now same. So it means the probabilities are also same. So probability of E3 is equal to probability of E2. And probability of E2 was 2 by 3. So therefore probability of E3 is also 2 by 3. Then we shift to next question. Question number 5. Fourth you can solve. In fifth, from a well-shuffled deck of 52 playing cards. Now here we will use the description of the playing cards and various events whose probability we have to check. One card is drawn and we have to check the probability of a black card, not to be a red card, a face card and a face card of red color. So here is the solution. So total cards 52, cards drawn 1, so it means total outcomes 52. Even is the event that the card will be a black card. We know that total black cards are 26, so favorable outcomes 26. So probability is 26 over 52, that is 1 by 2. Then in second, E2 is the event that card will not be a red card. If the card is not a red card, it must be a black card. So it is same as E1. So probability of E2 is also probability of E1 and it is 1 by 2. In third case, E3 is the event that the card will be a red card. Then how many red cards are there? 26. So it means again 26 over 52. So probability of E3 is also 1 by 2. In fourth part, event is the card will be a face card and we know total face card, king, queen and jack, 4 each, 4 into 3, 12. So favorable outcomes to E4 are 12. So probability of E4, 12 over 52, that is 3 by 13. In fifth part, the event is red colored face card. So out of 12 cards, 6 are red, 6 are black face card. So it means red colored face card are 6. So probability of red colored face card is 6 by 52, that is 3 by 26.